Hi, Algebra 2, and welcome to your first lesson on shapes and end behavior for polynomials. So if I were you, I would start with some notes and I would write this down. So in the purple there, that's the title of our lesson today, Shapes and End Behavior of Polynomials. There are going to be 4 different categories that we are going to draw and look at. I'm going to share my screen with you so you can see what's going on, and then we'll practice a little bit at the end. So what I would do here is write down the first topic. So our first topic is we're going to look at just even exponents, and then when the leading term is positive. So that's supposed to be a plus sign right there. Okay, when the leading term is positive. So even exponents when the leading term is positive. And then I would just draw 3 pretend xy axes, and you're going to label them with x squared, x to the 4th, and then x to the 6th. You can pause this if you need to pause it, but I'm going to share my screen with you so we can take a look. So first of all, we already know what x to the squared looks like. We should know that that's a parabola, right? So let's go ahead and draw that in. Okay, so you can just draw that in as a fake little parabola on your graph. So I'm going to share my screen with you now, and we're going to take a look at what the polynomials for x to the 4th is going to look like. So let me change this to x to the 4th. All right, so here's x to the 4th. So let's take a look at this. This is what x to the 4th is supposed to look like. So if you notice here how it's similar to x squared is that it starts up here in the second quadrant, and then makes some little loops and comes up back to the first quadrant. So it's the same starting and stopping point as x squared, except for look what happens here in the middle. It makes a little Humpty Hump here. Okay, so this is a W curve is what we call it, a W, okay? So keep that in mind as we go and we move on to our next one, okay? If we keep looking here, same thing, that's not x to the 4th. There's an x to the 4th. We start here, we loop, 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 and we come back to the top. So an x to the 4th has a W shape to it. All right, let's take a look at what x to the 6th is going to look like. We'll draw this in our graphs in a second. Okay, so x to the 6th, this is an example right here of x to the 6th. So we're starting at the top, same spot that the parabola did. We come down here, look at how many times we're turning. We're turning once, twice, 3 times, 4 times, 5 times, and we're coming back up to the top. So what's happening as we increase the degree? Hopefully you're seeing that there's a lot of stuff going on in the middle here, and we're adding extra turns and extra humps and lumps into our graph. So let's go back to our main screen, into our notes, and let's put that in there. Okay, so x to the 4th, we're going to draw in so it looks like a W. It doesn't matter where you cross the axis. We're not concerned about that right now. So just make it look like a W, and it should have, if you notice here, it should have 3 humps. 1, 2, 3. 3 humps. Notice x squared only had 1 hump. X to the 4th has 3 humps. X to the 6th is going to have 5 humps. So that's 1 bump less than what the degree is. So we can go ahead and draw in that one as well. 1, 2, 3, 4, 5. And we'll make x to the 6th look like that. So x to the 8th, x to the 10th, we can keep going, but it's just going to get redundant. I think you get the idea between x squared, x to the 4th, and x to the 6th. So here's the important thing out of these shapes is that we understand the number of terms, okay, or the number of turns. So x squared had 1 turn, 1 hump, 1 less than the exponent. X to the 4th had 3, 1, 2, 3 turns, 1 less than the exponent. X to the 6th had 5 turns, 1, 2, 3, 4, 5. Boom. Okay, so that's important. Now the next thing is their end behavior. So the end behavior is kind of like you're reading a book. And when you read a book, you read from left to right, right? So if we read from left to right, where is the parabola going here on the left? It's going to positive infinity. Up here is positive infinity. If it were to keep going and going and going, it goes positive forever. Then it does its turn, and then it shoots back to positive infinity. So that's how we say the end behavior is. We say that it starts on the left, because that's how we read a book. It starts from positive infinity and it shoots back to positive infinity. The same thing happens with x to the fourth. We start at positive infinity, draw a, and then does this thing, do, and then shoots back up to positive infinity. Yikes. Okay, same thing with x to the 6. It starts at positive infinity, does whatever it does in the graph, whee, and then bounces right back to positive infinity. So the important thing here is that even exponents that have a positive leading term start at positive infinity and go to positive infinity. So starts and ends at positive infinity. You want to make sure you put that in your notes. That's a very important piece. Okay, let's move on. So the next thing we're going to do is we're going to do odd exponents with a positive coefficient. So at the top there, we're going to put number 2 now instead of number 1. So we're going to do odd exponents. And the first term is positive. Okay, odd exponents, first term is positive. And we're going to draw 3 graphs again. And this time we're going to start with just an x, because remember, x is to the first power. So we're going to do just an x to the first power. We're going to do x to the third, and we're going to do x to the fifth. Okay, so that's what you want to get down in your notes. And then we're going to take a look and see what those mean. Now, hopefully you remember that x to the first is your plain old good old-fashioned linear equation. So just a line. So we're going to go ahead and draw that in because we know what a line looks like. Doesn't matter if you want to draw it through the center, that's fine. Doesn't matter. Okay, let's take a look at what x to the third and x to the fifth are going to look like. Now, x to the third is going to be a really big focus for us in this unit. But let's take a look. I'm going to share my screen. And we're going to take a look and see what good old Google tells us about okay, so let's pull up x to the third. Okay, so these are all great examples of x to the third. So this is the basic one, the parent function that goes through the center. So your x to the third, if you notice here, is called an S-curve. Okay, so it's starting at the bottom instead of starting at the top, like the even exponents. We're starting at the bottom, but then we're traveling to the top. Okay, here's another example. Start at the bottom, woo woo, do 2 dips and come to the top. So this is called an S-curve. X to the third looks like an S-curve. This is not x to the third. This is x to the third. These are both x to the third. Okay, let's take a look now at what x to the fifth looks like, and then we'll graph these on our paper. Okay, here is an example of x to the fifth. Holy cow. Okay, so again, we're starting at the bottom, and let's watch how many times we turn. So we're coming up here, we're turning 1, 2, 3, 4 times, and then shooting back up to positive. Okay, let's look again at this one. This is also x to the fifth, starting at the bottom, shooting up to the top, 1 turn, 2 turns, 3 turns, 4 turns, boom, back to the top. So this should seem pretty similar to what we just did with our even exponents. Okay, so our x to the third, we're going to draw in with 2 humps. Okay, so again, that should make sense based on what we just did. X to the third is 3 powers, but we are going 1, 2 humps to come back to the top. Okay, x to the fifth, guess how many humps we're going to have in x to the fifth? 4, should be 1 less than. So here we're going to go 1, 2, 3, 4, and then shoot it back to the top. So let's make sure that we have those in our notes. So we have the basic shape of what x to the first power, x to the third power, and x to the fifth power look like. So important things here is that, remember, x to the first has no turns, which makes sense. That's 1 less than its degree, no turns. X to the third has 2 turns, 1, 2, 1 less than the degree. X to the fifth has 4 turns, or 4 humps, 1, 2, 3, 4, x to the fifth. So x to the seventh would have 6 turns, x to the 9th would have 8 terms, so on and so forth. Okay, the other thing we need to talk about is end behavior. So the end behavior is different, right? Because in the positives, or in the even exponents, we went positive infinity to positive infinity. But where are we starting here in all of these? We're not starting at the top anymore, we're starting at the bottom. So all of these are starting at negative infinity. Okay, again, we're reading it like a book, so we're starting on the left side. It starts from negative infinity, but then it shoots to positive infinity. So all these start at negative infinity, but shoot to positive infinity. So what we're doing here is we're coming up with basic rules for different types of exponents and based on their first term. Okay, so the rule we want to write at the bottom here is we want to write for these odd exponents, we start at negative infinity, but we end at positive infinity. So down there in the purple is the rule for this family. Again, this family are odd exponents that have a positive leading coefficient or a positive first term. Okay, now let's explore what happens if we have negative leading coefficients. So we're going to go back to the even exponents for a second. So I will change this title. So we're on number 3 now, the third family. The third family are even exponents and negative first term. Okay, we're going to draw 3 graphs again. So here we go. Even exponents, negative first term. Draw your 3 graphs. X squared, x to the 4th, x to the 6th. Okay, now I know that you know this. So if I put a negative in front of this x squared, do you remember what happens to our parabola? If you have a negative in front, it's going to turn down, right? It's going to flip over. So we're going to go ahead and do that. Let me draw that in purple for you. So what do you think is going to happen to all the rest of them? If they're all the same family, all the same characteristics, what's going to happen to the rest of them? Hopefully you're thinking, well, Ms. Sawinski, they're all going to flip down. You are correct. So x to the 4th is also going to flip down. So it's going to look like this. So instead of a W this time, when it flips over, it's going to look like an M. So still make sure that you have 3 humps. And then what do you think will happen with x to the 6th? How many humps is it going to have? It should have 5, and it should turn down as well. So it should look like this. 1, 2, 3, 4, 5. Boom. All right. So most important thing here is that we understand what happens to the graph. So if it has a negative in front, it's going to turn it down, or it's going to flip it. So now what happens to the end behavior? The end behavior is not positive infinity to positive infinity anymore. Now it's coming from negative infinity and going to negative infinity. Negative infinity, negative infinity. So both of them this time, so instead of positive, positive, it's going to be negative, negative. So your rule at the bottom is you want to write starts at negative infinity, ends at negative infinity. Starts at negative infinity, ends at negative infinity. Okay, last one. So now family 4 is going to be our odd exponents, and odd exponents with a negative first term. Okay, so go ahead if you want to draw your 3 graphs again. Odd exponent, negative first term. Okay, so do you remember with a line, we're going to start with x to the 1st, or just a good old line. So what happens if I put a negative in front of my line? Remember, my first line was going like this. Okay, it reflects. If you remember, it reflects. So instead of it starting at negative infinity, it's going to look like this. So it's going to start in the other corner at positive infinity, and it's going to go down to negative infinity. So the same thing is going to happen with the rest of the family. So it's just going to reflect. So instead of flipping, it will reflect. Okay, so instead of x to the 3rd starting negative, it's going to start positive. So it's still an S curve, but it's just flipped now. Same thing with x to the 5th. It'll start at the top. It's still going to have 1, 2, 3, 4 humps, 4 lumps in it, and then it's going to shoot down to negative infinity. So this time it's going to start at positive infinity and shoot down to negative infinity. So the rule here with our odd exponents with a negative first term, the rule is it starts at positive infinity and ends at negative infinity. Okay, and that's what we're going to be focusing on today. So I'm going to show you some examples right now as to how your homework would look like or what kind of questions I might ask you. Again, you can pause it now if you need to write this down before I move on. Great. Okay, let's take a look at some examples. So if you're numbering these, you could number this as part 5 as our examples. So I'm just going to show you 2, and then I will also post some more examples online if you want to go to a website that can show you a few more examples if you need more. So here's one example I might give you. Okay, I might give you a picture like this. So a picture of the graph, and I'm going to ask you, what degree of a polynomial would this be? And then I'm going to ask you, what would the end behavior be, or what would be the leading coefficient? So hopefully, looking at this and you look at your family that you have in front of you, you're going to notice that this is an even exponent because they both go in the same direction. Also, that this would be to the 4th degree because this is an m and you have 1, 2, 3 terms. So this is going to be a 4th degree polynomial. So you can write it as x to the 4th, you can write 4th degree polynomial. My next question would be, well, what kind of coefficient would it have? What would be the leading term? Would it be positive or negative? You would say that it would be negative because it's turned down. And then my last question might be, well, what type of end behavior does it have? And you would say, well, it starts at negative infinity and goes to negative infinity. So you would have negative infinity to negative infinity as another answer. Okay. Now, it may not be a graph that I give you. It could be an example. So I might, or a function. I could say f of x equals x to the 3rd plus 4x minus 5, something like that. I could just give you an equation and I could say, what degree is this? Now, this is probably pretty easy because it's clear that this is a 3rd degree. Okay, but I might put it in a different order and make you think a little bit. You never know. But I might ask you, what degree is this? And then I may say, okay, could you tell me how many turns would this have? And if you remember, the turns are 1 less than the degree. So this should have 2 turns. Okay. I might also ask you then, what would be the end behavior? And so you would probably want to know what this looks like. Now, it'd be hard for you to sketch it on if I do a Google form, but you should know that the sketch of x to the 3rd is your S curve like this. So you're going to want to have that in your head and or have that on your notes so you can take a look at it. And then you're going to say, okay, I know this is what it looks like. So I know that 3rd degree polynomials that have a positive leading coefficient is going to go from negative infinity to positive infinity. Okay, so those would be the types of questions that I might ask you on your homework. So again, I will post some examples for you to look at as well, but otherwise, let me know if you have questions. Good luck.